All right, 4.1, in these problems, they ask you to graph these functions, not by plotting points, but by using what you know about transformation. And then it asks for the domain, the range, and the asymptote. Now let's talk about the parent function first. So I've already drawn the parent function of these two graphs. And like I said, they want you to use transformations here, so you're not getting bogged down in these graphs. You should have a general idea of what these graphs look like, but they are all on page 332. Notice that they all are going to go through the point 0, 1, and they're all going to be approaching 0, one way or the other. They're going to approach 0. So your asymptote is going to be y equals 0 for all these parent graphs. Now, 32 is g of x equals 2 raised to the x minus 3. So I'm looking to see what is happening when I transform this graph. Well, the transformation is coming from the x minus 3. Now notice this x minus 3, this is together. That means this is shifting to the right, the opposite sign, 3. So it's shifting to the right 3 units. So now I'm looking at this and thinking, all right, all I'm doing, now instead of going through 0, 1, I'm going to be going through 0, 3, because this is shifting to the right 3 units and still going up. All right, it asks you to find the domain. The domain is not going to change. I don't have any restrictions on my domain, so my domain is always going to be negative infinity to infinity. My range, notice my range, my range are my y values, so I'm starting at 0 and I'm going to infinity. Now, I don't touch 0 or cross 0, I just approach it. So this is going to be a parenthesis with that. And then my asymptote is going to be y equals 0. All right, now in 36, let's see what's going on with 36. So 36 is actually not the right problem. I think that's supposed to be a negative x right there. All right, so 36 is y equals 5 to the negative x minus 3. So when you're looking to see how you transform this, this has got two transformations in it. Use your order of operations. So you're going to deal with that exponent first. So I've got 5 raised to the negative x. Well, if I make my x values negative, let's pretend they're all over on the right side. If I make them negative, what's going to happen? That's going to reflect it over the y-axis. So all I'm doing is folding this on the y-axis. So now this isn't going to be my final graph, but if I folded it or reflected it on the y-axis, now it's doing that. All right, so that took care of my first transformation. Then I'm taking this entire function and I'm subtracting 3 from it, which means I'm shifting it down. And I should write this out. So I'm reflecting over the y-axis, and then I'm shifting down 3 units. All right, so my final graph is just going to take this and I'm going to go down 3 units. All right, so let's answer the questions. They ask for my domain. My domain has no restrictions. It's still going to be negative infinity to infinity. Let's look at the asymptote first. All right, so we've got y equals, so there's my asymptote. Now, if I took this graph and shifted it down 3, instead of my asymptote for my parent graph is y equals 0, always. But if I take this graph and shift it down 3, now my asymptote is y equals negative 3. Notice on this first problem that my asymptote was y equals 0. Well, I didn't shift it up or down. I just moved it to the right or left, so my asymptote wasn't affected. In this one, however, when I shifted it down 3, now my asymptote is y equals negative 3. This is also going to affect my range because my range is now starting at negative 3, which is not included, and it's going to infinity.